Welcome to the second lesson within the suite for Data Gap Suite BI Validator. In the previous lesson, we looked into how we can attach BI sources within the application. Today, we are just going to finish the example properly by connecting to a BI source and then correspondingly applying a basic set of aggregates to them. So the first aspect is quite straightforward. In this example, I'll be using Power BI nodes within my system. As a refresher, all you have to do to connect to Power BI or Tableau is define the connection and you're good to go. I'll be using some existing demos to speed up the process. As we discussed in the previous lesson, if you want to pull up data sets from your BI specific system, all you have to do is either go to visuals or worksheets and data sheets to pull the specific data set out. Now, in this particular example, we are not getting into the depths on how exactly we can apply filters and parameters. However, doing this is quite straightforward. You see, if your corresponding report, whether it's a BI, Power BI report or Tableau, will have specific filters associated with them. In case of Power BI, these filters are at a level of report, page, and visual. In Tableau, on the other side, you'll see these filters applied at an overall level as well. In either cases, the application has the capability to capture these filters. If you don't see a particular filter, say in the case of Tableau, try adjusting the filter values. That way, the application will definitely register the change and thus will capture that particular filter value as well. Or else, in most cases, those filter values should be instantly brought into the system. And you'll see a window similar to this where you can either choose to edit this particular set of filters, either by giving them specific operators and giving a manual value or parameterizing a value and adding it. And again, this is all is customizable to a great degree. So again, feel free to try this specifically for your specific examples. For the sake of our demo, we'll be proceeding without a bookmark and we'll be running this specific test case. Now, what is a bookmark in this case? Well, if you ever work with any kind of BI reports, you understand that there are states of a report. So what I mean by states of a report are, if you click on some particular event, or if you apply a specific slicer, or if you click on an element specifically, you'll see the report is dynamically changing because now the report is filtered for that specific element. So our application is capable of identifying that as a bookmark itself. And so when you define that as your bookmark, the application will just run the whenever the application is running the test case, irrespective of what state the original report is in, the application will apply those same bookmarks and run accordingly. It's very similar to how we can apply filters because internally bookmarks are technically filters, but their application takes care of it from two distinct methods, either by filters or by bookmarks. Use the one that you feel is the most important for your use case. Now that we've pulled data sets out of our system, again, I've pulled out just one data set. I can pull out multiple. I can rename this as well. Let's get our aggregates down. Now, in our example currently, I'll be using a SQL Server as an aggregate. So let me use AGG for aggregate right here. And again, this is going to be a direct JDBC connection itself. Alternatively, what I can choose to do is pull out individual tables and then use a SQL or Python node to do this. But in this case, for the sake of simplicity, I'll be sticking to a fewer set of nodes. Also, if you have already created data models within your system, if you have not, feel free to look at the documentation or other videos for the same. You'll notice that I can directly use my query builder for this particular use case. So, in this example, if you remember, we are looking at yearly income upon total children, and both of these columns come from dim customer. So I add the column within dim customer for yearly income, and then I also add one column which says total children. And since we are looking at yearly income as an aggregate, let's give it a sum. And you'll see my query has been automatically built. This function is very helpful, especially if you're working with tables with multiple joining keys and other aspects, as the application can take care of these joining keys, even if there are one-to-one, one-to-many, or cross-table transactional, implying that if you want to reference table 3 from table 1, when there's no direct correlation between table 1 and 3, but there is a correlation between table 1 and 2 and 2 and 3, the application can handle those joining keys as well. Of course, before I actually run the actual aggregate, I'm going to preview it. I'm going to see what the test case looks like, and this looks more or less what I'm working with. And so I'll run this node. From a technical perspective, what's happening in the backend once again is, since we are based on Apache Spark, the application is, and this particular session is live, the application is running real time. And we have pulled in Power BI data set and we have pulled in some aggregates from or SQL Server as well. Once again, the alternative is to bring in data sets from different locations and use processor nodes instead of processing them within the source itself to do this. If I was working with the CSV file, it's not exactly possible for me to apply an aggregate while I'm pulling the CSV file itself. So I pull the CSV file or I pull the JSON file. Then I either use SQL, Python, Scala, or other processes to aggregate the system. Now that I've created this, let's go with the main aspect, which is data comparison. And I'll create my dependencies as Power BI and aggregate here. And the only thing I have to do is select what I have to work with here. So here I define these are the two data sets I want to work with. I'll enable automatic data type conversions and they should be good to go. Next, well, the application has automatically mapped everything accordingly. The only thing left for me to do is map total children right here, as this is the unique key. So the main point of unique key, what unique key is, and what I'm trying to do in this particular node, is a data compare is a full data comparison. And so even if you have say two distinct data sets which have different column names, which have different column orders, which have different number of columns itself, and different data types, as you can see, the application can ease the process of comparing these data sets automatically. Even if I'm working with say a discrepancy of 5 columns to 20 columns between dataset A and dataset B, you don't have to worry about that. The application will map just the 5 columns it sees fit, and this is done automatically. As you see, sum of yearly income was automatically tagged to yearly income sum, and I can remap them based on name and choose how much these strings or these names have to match using fuzzy logic. So I have a lot of control there, and the other options are along the same lines itself. I can manually add columns, remove columns, change data types on the go, as you can see right here if I have to, and of course add some thresholding values as well. So here we'll just add a thresholding value of 0.5 and 0.5, or let's make it even low, 0.1, sorry, let's make this minus 0.1. So what this implies is that if my target and source numeric or decimal values are outside of these up bounds between each other, the application will call them out as a mismatched records. Now let's run the system. Once again, the application takes care of most of the things for you. It's going to take care of mapping, it's going to take care of data type conversions, it's going to take care of irregularities between columns and other aspects. And in fact, you get a great amount of control on how the data comparison works as well before you actually run them. And here you see how we have, in a very short period of time, created an aggregate and pulled data sets out from Power BI and run a comparison against them. The example I'm working with is a highly simplified bar graph, but as we've discussed in our sources lessons, even if you're working with really complex data sets or complex graphs for that matter, the application can handle them. And the data compare node is built to withstand migration validation use cases for trillions of records, so the application can easily work with really huge data sets and huge number of records inherently. So that should never be a problem here. Now, looking at the results, we see that, well, something has definitely gone wrong here. We see that, yes, there's been a mismatch, and we can zoom into that and see that, yes, this mismatch is about 45K, and we were looking for 0.01. And the one mistake that I've done here on purpose here is that we are looking at percentages, not total numbers. If I go back to percentages and I rerun the system, you'll see that instead of the difference, the raw difference of acceptable criteria, which is a raw number previously, now it's a percentage, and now we'll ensure that we are more or less between the source and target. And so yeah, along with the other aspects that you see here, one key aspect about the application is that whenever you're working with any kind of data rules or data compare or other aspects of the application, you'll notice that the application has a good amount of segregation built in, implying that the application can easily segregate your good and bad records. You see it live within data compare, where the good records are present right here and the bad records are once again right here, as we see. And if there were any duplicates or if there were records present in one system and not the other, those would have been caught in the other subsequent systems. I'll showcase this towards the end, hopefully, if time permits. But yeah, in this particular sense, what we have basically done is very simply, we have created a very simple system which basically ensures that we can find aggregates within our system. And if I wanted to parameterize this, all I have to do is go into data flow parameters. Let's add a new parameter. Let's call it gender. Let's give it as MF. Now that I've added my system here, let's make sure we have the same within our aggregate. As you might imagine, it's very important for us to have this within our aggregate itself, right? So let's add the condition, a dim customer, it's on gender. Let's not starts with, let's make it is equal to, for now I'll give it the value M, and I'll apply the query. But here's what I'm going to do, the smart thing here. Instead of having it as I'm right there, let's make sure we apply it as a gender. There we go. Now we have parameterized our filter. And of course, before running this, we need to parameterize our Power BI report as well. So I go back to reports. I go into filter. Once again, this the application is pretty similar with Tableau as well, and I'll use another example for Tableau for data rules. But for now, please stick with me here. Let's go for pages, and within this particular system, let's make sure that we have in, and let's add our parameterized value of gender. There we go. So now what we've basically done is that we have ensured that the data sets that we pull in from our reports now, with these data sets are going to be with the application of our male filter, and the same aggregate will be done, same filter will be applied when we create our actual aggregate from our data source, which in this case is SQL Server. And so what we have done is now we're validating our reports not just at an overall level, but at a zoomed in level after some application of some filters. Now, before I move on to the other use case, there is a quick caveat I want to take into account. In real-time use cases, you might be facing much more difficult, or in this case, complex use cases where you don't have just one filter, you have multiple slices and filters. And the use case is a bit limited on the fact that it's not that you want to choose or apply just one filter and check. You want to apply multiple filters. You want to apply a combination of multiple filters and check your system. And the application is capable of doing that as well. The way to do that is by the application of a specific plugin. And I'll just quickly show that plugin before we move on to the other use cases. So the plugin in question is a very basic plugin that takes into account the different data sets that you're working with here. So I'll just open it up right here. There we go. So this is the plugin that we're talking about. So again, you need to provide it a file or a view or any kind of data set within the following format, which has a configurations and then different values for different data flow parameters. So here the example takes into account the start and end date of a specific parameter. And then the plugin is just something that we have defined to just plug into our entire pipelines. The final use case of this plugin is when you get into pipelines, which we will discuss shortly. You'll have a node called iterative tasks iteration, and what this basically asks of you is, let me go back to an example where we are using this. And what this basically asks of you is, well, if you want dynamic sets, where is the dynamic data set coming from? And this is what's being populated by the entire plugin. And if I go into the run history, you will see that when we have run this particular cross check, when we have actually run this test case, we have not run this test case just once. We have run this test case for each and every configuration that we have defined. So each and every combination of parameters that we have defined. In upcoming releases, this particular file itself of combination of parameters will be generated by data gaps automatically. But for now, we ask our users to define these based on their expertise on the dataset and the BI report. Going back to our use cases, now let's quickly pick up a Tableau system, and now let's take into other use case, which is applying rules. Now, the application of rules is once again straightforward here. I'll use Power BI for now and we'll stick for regression for BI as it's pretty similar. The main aspect of applying rules here is quite straightforward. If I have a set of filters, or if I have a set of rules that I want to apply to my filters, or do I want slicers, or if I want to apply to multiple data sets, all I have to do is pull these data sets or slicers or other aspects out. Yes, slicers are also part of visual, so we can pull them out as well. And then instead of applying a data compare on them, I'll drag and drop a data rule here. Let's make sure we're going to Power BI. And once I'm in data rules here, all I have to do is pick up the corresponding aggregate. And now I get a great amount of rules I can apply from the get-go. This includes everything from null checks. So let's apply a basic null check right as we speak. I want to ensure that my total children are never null. So I'll just apply total children is not null as a good record condition. Next, I want to ensure that there are no duplicates for my system. Once again, I just choose where I don't want any duplicates. That's it, and I'm good to go. I want to ensure that my yearly income is never less than zero. Once again, attribute rule comes into picture, and we'll make sure that yearly income is greater than or equal to zero. So in this particular way, what we've basically done is that we've ensured that our data sets follow a specific set of rules. We highly expect our end users to implore and see the different types of rules that we can work with, as all of these rules are importable and exportable, and you'll see that we have just scratched the surface of what we can do with our rule system. This is the tip of the iceberg, so we get really deep with these exact type of use cases. And once again, we expect our users to really dig themselves deep into this particular rabbit hole to understand that the application can actually do a lot more than just what's on the surface. Of course, we're more than happy to help you at any point. So if there are any questions, feel free to contact us directly using our support portal right here or using our mail. Now, with that out of the way, let's get to another system, which is regression. Now, I'll be using Tableau for the specific test cases. So, what do we mean by regression here? Well, sometimes you have this particular use case. So, I'm going to just drag and drop Tableau grid and illustrate what I mean. Where I have a QA environment and I have a production environment. This can be for any two BI tools. And I want to ensure that these reports are actually in sync. So, the way I do that is, well, I can choose the same connection if I have the same connection for both. So here I can choose both, but I can choose different connections as well. And in comparison options, I'll just make sure I can actually see the differences being laid out. So what do I mean by differences? Well, let's go ahead and add our QA report, our developer report, and our production report. I have these examples curated right here. I'm going to select the dashboard for both of them. So as you notice, in a few seconds, we'll actually load our embedded Tableau system right there. And once this is loaded, we'll do the same for our another second report as well. All right. So in the second one, I'm going to start uploading the production one as well, as we see. And again, all we are doing is waiting for the corresponding Tableau system to load up. It might take a bit of time if your Tableau system, like currently mine, is actually overloaded at this particular point, as I've checked. And since we are technically a user trying to accept the system, this is something that could happen, especially if your Tableau system is overloaded. So sometimes you're giving it a quick check might be helpful. There we go. So now that we have Tableau report A and now we have Tableau report B loaded as well, you'll notice these are pretty similar reports, and that's by intention. The main aspect of our report section here is to ensure that these represent a QA system and a production system. So here we see this is a QA report. That's why it's in development, and in report B is actually a production report. And as you see, it's pretty similar in most senses, and from just looking at it, you might not find a lot of differences. But now in the results, when I run the system, you'll see what we are trying to do. You see, if your problem statement is anywhere with regards to ensuring that two distinct reports from any two distinct locations, or even the same location for that matter, are in fact the same. Now, again, I've used the example of QA and production being in sync. The example could also be ensuring your on-prem and your cloud systems are in sync. So if you're, say, working with migration process, it's a very typical ask that your reports which were originally pointing to the on-prem system is now pointing to the cloud system. So it's very important for you to ensure that the reports are actually matching even after the migration. And in other cases, you want to ensure sync, or in other cases, you want to ensure the reports from both systems are actually being valid. And that's what the application is doing as of now. You see, we have actually captured differences within our report. And there are two types of differences we have captured. The first type of difference is, of course, with regards to text. As you see, sales of ship mode, sales per ship mode, this is incorrect. And there's an addition of a new filter altogether that we have captured. And any kind of changes like this are being captured. But if you want to move away from text, the application can also capture appearance. And here we'll see, yes, there are differences being highlighted from the text perspective. But you'll notice if we zoom in for ship mode specifically, that the graphic, the placement of this particular filter has been altered as well. It's moved up a little. In the same way, there are multiple examples where we can actually illustrate that if you change your data, so if you can actually choose that if you want to, say, eliminate the change in data, you want to capture only your elements, the application is capable of that. Alternatively, if you want to capture data changes as well, so here, if there were any data changes, the application would have captured those as well. But in this particular example, we are capturing only the UI changes. Let me quickly go to an example where there are data changes as well, just for the sake of illustration. Yeah, so what we would like to showcase now is just another regression use case itself, except here we want to actually showcase an upgrade test plan as well, or regression test plan. And here we see that, well, the test case is failed. And in this case, you'll notice that instead of report A and report B, there's benchmark and results. And if I actually dig deeper, you'll see that the numbers are different. But if I move to appearance, you'll see that even the color changes and other aspects have been accepted. Now, the main reason that we are trying to illustrate this is the reason this is different from an upgrade test plan. If you'll notice, we have upgrade test plan here as well. Is that in regression, the use case that you want to solve is not that you want to compare two reports. You want to compare the same report against itself. Let's see why you would want to do this. You would want to do this for one specific reason, which is that, well, say each and every quarter when Tableau upgrades, all your reports are messed up because Tableau inherently changes the alignment of your reports or something along those lines. And so you want to ensure that even after an upgrade, the report stays the same. Alternatively, you've noticed that when anyone works on the transformation pipeline, your reports inherently get inadvertently gets changed. And so, well, that's a bit of problem because you always have to backtrack and see which change caused this particular issue. And what you can do instead of that is, well, select the report that you want to work with. In this case, define it. I mean, you've selected this particular report. That's good. Now, go to benchmark. And what benchmarking is going to be is that it's going to take a screenshot or a snapshot of the report with all the filters applied, with all the data sets you're using, and other aspects as well. Now, whenever you run this particular test case, the comparison is going to be with the latest version of the report against the benchmark. And so, if there are any differences, say someone has gone and changed some filters, someone has gone and changed the transformation logic, or someone has changed data sets, the application understands that and will capture it. And so, you'll be the first one to be notified in case there are any changes to your report that you were not expecting. So, in this particular way, the application handles regression to a great degree as well. So, in this particular lesson, we have covered Power BI and Tableau with regards to some use cases that we have covered, mainly the comparison use case and, of course, the regression. We use Tableau and Power BI interchangeably within our application, as for the application, these are data sets and reports interchangeably, so you can work with them accordingly. And in case of any questions, feel free to message us directly or use our support portal, as you can see right here. And in the next lesson, we'll be covering the automation of generation of these test cases altogether. And of course, we'll also talk a bit about pipelines and scheduling as a whole. The next lesson should be the last one. In case there are new features added, we will have to, of course, add more lessons as we go along. Once again, if there are any questions, feel free to pause us at any point or message us directly. Thank you.